Hello everybody, welcome to our NEET Physics by your own video channel. In today's video, we are going to solve an MCQ in the chapter Waves, which is in your class 11 syllabus. The question is, consider two uniform wires vibrating simultaneously in their fundamental modes. The tensions, densities, lengths and diameter of the two wires are in the ratio 8:1, 1:2, x is to y and 4:1 respectively. It means what? The ratio of tensions 8:1, density 1:2, length x is to y and the ratio of diameter is 1:2. Okay, so if the note of the higher pitch has a frequency of 360 Hz and the number of beats produced per second is 10, then the value of x is to y is how much? X is to y means what? The length of the string, the ratio of the length of the string is how much? As usual, you are given four options. A 36 is to 35. B 35 is to 36. C 1 is to 1 and D 1 is to 2. What is the answer, sir? That is, it's a lengthy problem. Okay. So we know that the frequency is given by the equation F is equal to 1 by 2L into root of T by mu. What is mu? T is the tension in the string, L is the length of the string, for which the ratio you are going to find out. F, frequency of the fundamental node, and mu is the linear density. But remember, here only the ratio of densities is given, not the linear density. And you have to find the relation between density and linear density. Okay. So what does it mean by linear density? Mass per unit length. Mass per unit length. So I have to proceed. Mu is equal to mass by length. It means mass per unit length. Multiplying the numerator and denominator of this equation by the area of cross section. What is the formula of area of cross section? The wire will be a long one. It is a cylindrical wire, and its area of cross section will be like a circle. Is it not? So it's the area of cross section. A is equal to pi r square. Here r is the radius of the string. So multiplying the numerator and denominator by pi r square. So mu is equal to mass into pi r square divided by length into pi r square. What is pi r square into length? What is length into area of cross section? It will give you the volume. Okay. So the numerator is mass as usual, mass into pi r square, mass into pi r square, and the denominator is length into pi r square is equal to volume. What is mass by volume? Density. So mass by volume is equal to rho is equal to density, whose ratio has been given in this question. The question. So we get mu is equal to rho into pi r square. Mass by volume is equal to rho into pi r square. Mu is equal to mass by volume rho into pi r square. Mu is equal to rho into pi r square. That is mu is equal to rho into instead of r, you can say d by 2. R is the radius. Radius is equal to diameter by 2. So d by 2. Because the ratio of diameter is only has been given in the problem. Radius has not been given. So d by 2 square, of course. So that is mu is equal to rho into pi d square divided by 4. Of course, I already told you that d is the diameter of the string. You have a long way to go. Now we can write it as equal to 1 by 2 into square root of t. Instead of mu, you write rho into pi into d square. Oh. It is equal to 1 by 2 L. This 4 is in the denominator, will go up. So then the numerator inside the square root will be 4. This 4 will go up. So 1 by 2 L into square root of 4t divided by rho pi d square. Rho pi d square. So when this 4 comes out of the square root, it will become 2. So instead of 1 by 2L, you write 2 by 2L. Similarly, you have a d squared here inside the square root. When it comes out, it will become D. So instead of 1 by 2L, now the factors outside the square root is 2 by 2LD. What is inside the square root? Square root of T by rho into. D square எடுத்தாச்சு, rho into. So F is equal to 2 and 2 gets cancelled. 1 by LD, 1 by LD, square root of T by rho. This is the new equation for the frequency of the string. Now it has been given in the problem that frequency of the note of higher pitch, let it be F2, 360 Hz. Frequency of beats N is equal to 10 Hz. You know that the beat frequency N is equal to F2 minus F1, difference between the frequencies. So F2 is 360, then what is F1? Put F1 on this side and put N this side. So frequency of note of lower pitch F1 is equal to F1 இது வந்துருது N equal to F2 minus 360 minus 10 is equal to 350 Hz. So now we have F1 is equal to 350 Hz and F2 is equal to 360 Hz, which has been given in the question itself. Now we can write the equation. F1 is equal to, already we had a equation, new equation for the frequency. F is equal to 1 by LD and the square root of T by rho. Now we can write separate equations for F1 and F2. So F1 is equal to 1 by, for the first wire, frequency is F1. For the first wire, length is L1. For the first wire, diameter is T. Square root of, for the first wire, tension is T. Divided by pi into, for the first wire, density is 1. Similarly, and F2 is equal to 1 by, for the second wire, frequency is F2, length is L2, diameter is D2, square root of tension is T2 by density rho. So F1 by F2 is equal to 350 by 360 is equal to T1, D1. Sorry, 1 by L1 D1, 1 by L1 D1 into square root of T1 square root divided by root of pi rho, root of pi rho. Then for F2, you have to inverse the expression. 1 by L2 D2, by L2 D2 will go to the numerator into square root of T2. So pi root 2 will go up by square root of pi 2. Okay. Now the ratios are the new question. Tension T1 is to T2 is equal to 8 is to 2. That means what? T1 is 8T, T2 is T1E. Density rho 1 is equal to rho 2 is equal to 1 is 2. So rho 1 is equal to 1, rho 2 is equal to 2. Length L1 is to L2 is equal to x is to y. This is what you have to find out. D1 is to D2 is equal to rho is to. So you can apply all these ratios. Say F1 by F2 is equal to 350 by 360 is equal to T1, 8T divided by root of T. Diameter y into, sorry, length y. Length L2 is equal to y. Diameter D2 is equal to D. So into square root of pi into 2 rho. Rho 2 is equal to, rho 1 is 1/4, rho 2 is twice that of rho, isn't it? So 2 into, this is 1 into. So a square root of 8t into yd into root pi 2 divided by square root of t2 is equal to t. Then L1 x, L1 is equal to x. D2 is equal to 4 is to D. Sorry, D1 is equal to 4 into D. D2 is equal to D1 into D. So into pi. So for the first wire, we are writing L1 instead of L1 D1, we write x into 4x, x into 4D. So instead of pi rho 1, you write, sorry, instead of T1, you write root 8T. Instead of pi rho 1, you write square root of pi rho 1, square root of pi. So square root of 8t divided by x into whole d divided by square root of 5 root. So these are all for first wire. And for second wire, square root of t, this y into d, the square root of 5 into 2. So these are for the second wire. So now you can cancel this. T and t gets cancelled, d and d gets cancelled, rho and rho gets cancelled, pi and pi gets cancelled. That is equal to square root of 8y into 2. 8y into 2. So all these things are in the square root. Okay? Then in the denominator, 4 into x. So d and d is cancelled. 4 into x. So it is equal to 8 divided by 16. Square root of 16y divided by x. It is equal to what? F1 by F2 is 350 by 360, 4y by 4x. It is equal to y by x. So y by x is equal to 35 by 36. That is x by y is equal to the reverse is the inverse 36 by 32. So x is to y is equal to 36 is to 30y. Answer A is the right answer. Okay. So we will see one more problem in our next video in the same chapter waves. Till then, thank you one and all.